So in this video, we're going to talk about quadratic transformations. So our parent function for quadratic is going to be y equals x squared. So to transform this, we have y equals some dilation factor times x minus h squared plus k. So let's discuss what these variables mean. For a, our dilation, this makes it wider or narrower, depending on the value of a. So if a is greater than 1, then the entire thing is going to be narrower, because the y values will be bigger, or they will increase at a faster rate given the same x value. And we can look at this using tables. So let's say I have this x value, and then I have y equals x squared, y equals, let's say 2x squared. And let's make a table for these values. So if I have 0, say 1 and 3, and then negative 1 and negative 3, so 0 squared is still 0. And then we have 1 and 9, then 1 and 9. Then if we multiply them by 2, then this becomes 18. This is 2, this is 0, this is 2, this is 18. So these y values are going to increase at a faster rate, thus making the graph narrower. Then if a is less than 1 or greater than 0, meaning it's a fraction, then the quadratic function is going to be wider. And let's extend our table over here and say y equals, let's say 1/3 x squared. So if we take the x squared value and then just divide them by 3, then we get 3, 1/3, 0, 1/3, and 3. So this graph is going to look wider and more flat. Now, if a is less than 0, meaning it's negative, then the graph is going to open downwards. And all that means is, instead of the usual upward facing parabola, then it's going to open downwards. So if we look at different a values for our parent function, y equals x squared, we have the parent in black. And if I have a 2x squared, where a is greater than 1, then it's going to be narrower, and that's shown in blue. Then if I make it even bigger, if I make a even bigger, let's say 10x squared, then it gets even narrower. So the bigger a gets, the narrower your function is going to look on a graph. Then on the other hand, if we have a fraction, let's say 1/3 x squared, the same one we made a table for, then it's going to look like this. So it's going to be wider than the original function. And then I can make any fraction that's less than 1. The smaller the fraction gets, the wider it's going to look. So this 13/187 x squared is going to be the widest out of all of these graphs. Then we have our translations. And these are the h and the k. So with h, this is our horizontal translation. And the thing to remember about it is it's always the opposite, because it's x minus h. So if we have a negative h value, then it's going to the right. If we have a positive h value, then it's going to the left. And we will see this demonstrated on a graph as well. And then for the k, this is going to be our vertical translation. And this one is more self-explanatory. So if it's a positive k, then we're going up, and if it's a negative k, then we're going down. Now, if we want to look at our horizontal translations, the h value in the graph, then if we have an x minus 4, then we said that it's always the opposite. So it's going to move to the right 4. So now our vertex is going to be shifted over to 0, 4. And then if we do x plus 15, then it's going to move us to the left 15 because it's the opposite. So that's what that would look like. Then for the vertical translations, then this one is going to give you exactly what you put in. So if we have x squared plus 13, then it's going to go up 13. And then if we have x squared minus 8, then it's going to be down 8. So now we look at actually combining transformations for the quadratic function. So again, we have our f of x equals x squared parent function. And the first one we're going to look at is this g of x equals x minus 3 squared plus 2. So what we're doing to this function is there's no dilation, so it's going to be the same kind of slope. It's not going to be narrower or wider, but we're going to be moving 3 to the right and then up 2. So it's going to be that graph in purple. All we changed is the vertex and every other point that maps to it. Then we have h of x equals 5 times x plus 5 squared minus 6. So this time we're dilating it by 5, so it's going to be much narrower than the original. Then we're going to the left 5 and then down 6. So that's the dark red graph, where the new vertex is down here, and then it's much narrower than the original function. And then the last one is going to be 1/12 x minus 1 squared plus 10. So this one we're going to make it wider because of the 1/12. The a is less than 1 but greater than 0. And then the minus 1 is going to move us to the right 1, and then the plus 10 is going to move us up 10. So it's this green graph right here. Then a couple more functions we can look at with the negative slope then, or it opening downwards. We have g of x equals negative 7 times x plus 3 squared plus 9. So we know that we're moving the vertex over left 3 and then up 9, and then it's going to be narrower because 7 is greater than 1. And then we have that negative, so it's going to open downwards. So here we have our new vertex at negative 3, 9. Then it's narrower because of the 7, and then it's negative, so it opens downwards instead of up. And then the second function, negative 1/15 times x minus 5 squared minus 2, is going to move our vertex to the right 5 and then down 2. It's going to be wider because of the 1/15, and then it's going to open downwards. So here we have our new vertex at 5, negative 2. It's much wider, and then it opens downwards.